In this video, I'm going to talk about the operation and function of the link state routing protocols and specifically ISIS, intermediate system to intermediate system. You know that both of the ISIS and OSPF are link state protocol, and link state protocols is one type and also one kind of the IGP routing protocols, interior gateway protocols. First, we should understand the function and operation of the link state protocols, and after that we can talk about specifically on the ISIS. Let me start this video with the describing how one link state routing protocol can work. In the first part of this video, I'm not going to delve into the detail of, for example, ISIS or OSPF. I'm going only to describe the function of the link state routing protocols. After understanding the function of the link state routing protocols, we can talk about specifically on the ISIS function, okay, in the second part of this video. After this video, in the next video, we can configure ISIS, we can troubleshoot, we can verify ISIS. Okay, let me to start first with describing the function of the link state protocols in this scenario. As you can see in this scenario, here we have three routers, R1, R2, and R3, and these routers connected to the, for example, one LAN interface. As you can see, R1 connected to LAN net A with the address of net A, and also R2 connected to net B, and R3 connected to the net C. Also, as you can see, R1 connected to R2 in the subnet with the subnet of net AB, and R1 also connected to R3 in the subnet of net AC, and finally R2 connected to R3 in the subnet of NetBC. I'm going to talk about that how a link state routing protocol can work. I'm not going to delve into the detail of, for example, a specific routing protocol in this first part. This function, the link state function, is same between the OSPF and also ISIS. This is link state, not ISIS, not OSPF. Look at here. You know that in the link state function, every router in the, for example, network should create its link states. What is the link states? The link states of a router is the state of the links of that router. So easy. Let me to give you one example. In this example, we don't go into the detail of the one link state as we will see in the future videos. Only we will see a brief review about the link state. Look at here. Assume that R1 should create its link states. What is the link state of R1? This is the state of the links connected to R1. Look at here. R1 connected to net A, net AB, and also net AC. Because of that, in the link state of R1, look at here, this is the link state of R1, we can see that R1 says that I connected to the net A, this network, and also net AB, these networks, and also this network net AC. Also, I connected to the router 2, and also I connected to the router 3. This is a brief, for example, content of the link state of the router 1. This is the router 1 link state, or LSP, link state PDU. In ISIS, we say LSP, link state PDU. In OSPF, we can say LSA, link state advertisement. It's not important for us now. Let me to use the LS, means this is the link state of the router 1. I connected to net A, I connected to net AB, I connected to net AC, also I connected to router 2 and router 3. That's it. The second link state is the link state of router 2. This is the link state of the router 2. As you can see here, R2, such as the R1, should say about its link state. Look at here. It says that I connected to net B, and also I connected to net AB, also I connected to net BC, and also I connected to R1 and finally to R3. This is the link state of router 2. Also, as you can see here, we have another link state, the link state of router 3. Router 3 says that I connected to net C, I connected to net AC, and also to net BC. Also, I connected to the router 1 and finally to the router 2. This is the link state of the router 3. In all routing protocols that use the link state method, every router should create its link state. Okay, this is the first step. At the first step, every router should create its link state. After that, every router should advertise its link state to the other routers in that, for example, network. Look at here. As you can see, first R1 should send its link state to router 2 and also router 3. This is the link state of R1. The blue link LSR1 is the link state of R1. Now R2 has the link state of R1 and also R3 has the link state of R1. Also, R2 should send its link state, the red link state, look at here, to the R1 and also to the R3. Because of that, now R1 and R3, both of them have the link state of router 2. Also, router 3 should advertise its link state, this link state, to the router 1 and also to the router 2. Because of that, now router 1 and router 2 have the link state of router 3. And finally, all of these three routers, first R1, then second R2, and then R3, have its link state and the other router's link state. For example, in R1, we have one LSTB. LSTB means link state, okay, database of link states. In the LSTB of R1, now we have link state of R1, also link state of R2, and also link state of the router 3. And this is same in all of the routers in these networks. For example, in R2, also we have this LSTB include the link state of R1, R2, and also R3. Okay, this is the first and the second step. At the first step, every router should create its link state. At the second step, every router and each router should send its link state to the other routers in the network. And finally, every router and each router has for example, link state of itself and the other routers. This means that now R1 can imagine the map of the networks. Why? Because R1 now has the link state of itself and also link state of R2 and also link state of R3. And because of that, R1 now can imagine, can create, okay, can draw the map of these networks. R1 now can imagine that R2 connected to R3 and R3 also connected to net C and R2 connected to net B, for example, also R2 and R3. This means that after exchanging the link states, every router can draw the, for example, map of the network itself. This is the next step, drawing or, for example, creating the map of network in the mind of every router. And after that, every router can use itself as the root of the map, and with the SPF algorithm, shortest path first, find the best path to the other networks. For example, assume that R1 now draw this map in its mind. R1 can use this map to finding the best path to net B with the SPF algorithm, shortest path first, choosing best path based on lowest metric. Okay, I will talk about the detail of this feature, but for now we can imagine that the R1, after creating this map in its mind, can understand that the best path to reaching to net B is the path from the R1 R2 to net B. And when this path, for example, the link between net A and B doesn't exist, for example, it failed or it doesn't exist originally, R1 knows that it can send traffic for the net B toward the R3, and R3 can send the traffic to R2. Okay, this means that when you have the map of